Okay, guys. Pre-algebra, section 9.1, square roots. Thank you, Alfredo, for showing me how to get this stuff on here even when it's typed up and copying a selection from the PDF and just posting it in here. Thank you. That makes this a lot easier. All right, guys. Let's see. I'm going to sort of read through this simply because I think it's a good explanation, but we're just beginning to start work on square roots. We're going to work on the Pythagorean theorem with right triangles. We're going to actually talk a little bit about sine and cosine and tangent, which are trigonometric ratios, and I know none of that means anything to you right now, but it will. So, key ideas. When we square a number, we multiply it by itself. For example, 8 squared, or 8 to the second, is equal to 8 times 8, which equals 64. We know that, guys. That's simple. Welcome to the 4th grade, right? Now, when we take the square root of a number, we ask ourselves, what number times itself equals the number we started with? For example, the square root of 64. This little radical sign, I'm going to draw a little right here. That thing right there is called a radical sign or a square root sign. Okay? It asks us a question. What number times itself equals the number that's underneath? And in this case, 64. So what number times itself equals 64? Well, the answer, of course, is 8. But it can also be equal to negative 8. Because negative 8 times negative 8 is positive 64. So something that we have to remember here is that the square root of a positive number always has a positive square root and a negative square root. Okay? Now, look below, and I've got 3 things written here. The first one says the square root of 81 equals 9. The next one, okay, it says negative root 81 is negative 9. So you can see they distinguish. If they want the positive, they don't write a sign in front of it. If they want the negative, then they write negative root 81, and we get negative 9. Sometimes they want the positive and the negative, and we're going to see this little symbol right here. It's positive or negative root 81, which is positive negative 9. Okay? And guys, you're welcome to write that, but you always want to make sure you write the positive sign with the negative sign underneath. Okay? That's the way we always write that. Now, below that it says a perfect square is a number whose square root is a whole number, like 25, because 25 square root is 5. So 25 is a perfect square. 16 is a perfect square. 36 is a perfect square. 49 is a perfect square. 81 is a perfect square. I'm just giving you examples because they have whole numbers as their square roots. If the square root of a number, and now I'm starting right here, I'm sort of shifting gears, now I'm right here. If the square root of a whole number is not a whole number, then it's irrational, which means that we can't write it as a fraction. Okay? So let's take this for example. Let's take the square root of 24. Okay? Now the square root of 24 is less than the square root of 25, but it's more than the square root of 16. Okay? Now I'm going to simplify these things on the left and the right, here and here. Okay? The square root of 16 is 4. The square root of 25 is 5. But this number in the middle is somewhere, it's close to 5, but not exactly. It's going to be 4 point something, 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 right? And this number, because it doesn't come out to a whole number, its value cannot be represented as a fraction. That means that I cannot take an integer and divide it by an integer and get the square root of 24. The square root of 24 is sort of like pi. It goes on forever and ever, and it never repeats. So I can't just take its decimal form and turn it into a fraction, because its decimal form never ends and it never repeats. So I can't turn it into a fraction. It's irrational. Okay? So we need to remember those concepts, and remember the first section is always a lot of concepts and vocabulary, things that we haven't been talking about yet. So we're going to work with some of those now. It's going to go pretty quick, I think. All right? Good job, guys. I'll see you on example 1.